there is a planet that once appeared on serious maps of the heavens, given a name, fitted with an orbit, and tied to a country doctor who swore he had watched it cross the face of the sun, a man his nation decorated for the achievement. The only trouble is that the planet was never there at all. For nearly 50 years, it was hunted across the blazing disk of the sun by some of the most brilliant and careful people who have ever lived, who were certain, again and again, that they had caught it. How an entire age of science came to believe so completely in a world that did not exist is one of the strangest stories the sky has ever told, and it begins with the most dependable thing anyone could imagine: a universe that for 2 full centuries had kept very nearly perfect time. Isaac Newton had handed the world a single, quiet rule, that every object pulls on every other with a strength that fades in a precise and lawful way as distance grows. And from that one rule, the whole sky seemed to unfold like a machine made of glass, foretelling eclipses to the minute and taming the comets that had once frightened whole nations. And then there was Mercury, the smallest of the known planets, the one that hugs the sun so closely that it is almost always lost in the glare. Mercury moves quickly, circling the sun in just 88 days, and for that reason, it had long served as a favourite test of the Great Rule. If gravity truly behaved as Newton had said, then Mercury's path should be a settled, predictable, perfectly calculable thing. But Mercury would not quite settle down. To understand the trouble, it helps to picture how a planet really travels. We are often taught that planets move in tidy circles, but they do not. They move along slightly stretched loops, ovals, with the sun sitting a little off to one side. That means there is one point on each loop where the planet swings closest to the sun, and a point on the far side where it drifts out to its greatest distance. Now comes the surprising part. The loop itself does not stay frozen in place. Very slowly, the whole oval rotates so that the point of closest approach creeps a little further around with every pass, tracing out, over thousands of years, something like the petals of a flower. This slow turning of the orbit was expected, and most of it could be explained. The other planets, tugging on Mercury from their various distances, nudge its loop around bit by bit, and the patient mathematicians of the 17 and 1800s learned how to add up all of those gentle pulls. There was a second effect as well, a slow wobble of the Earth from which we do our watching, which shifts our measuring lines a touch over the centuries. When astronomers tallied every cause they could name, they could account for very nearly the whole of Mercury's strange motion. Very nearly, but not quite. What remained was a tiny, stubborn surplus. Mercury's loop was turning just a little faster than every known cause could explain, by an amount of roughly 43 seconds of arc each century. The sheer smallness of that figure is the heart of the whole story. Imagine slicing the great circle of the sky into 360 degrees, the way you might mark a compass. Slice a single one of those degrees into 60 smaller pieces, then slice one of those into 60 smaller still, and the slimmest sliver left over is a single second of arc. To picture something that size, imagine a small coin held up at the far end of a football field, almost 100 yards away. The width of that distant coin against the sky is about what we are talking about. And Mercury's unexplained drift amounted to only 43 such slivers, spread not across a single night or even a year, but across 100 full years of careful watching. It would have been easy to wave away as a rounding error, a speck that surely vanishes once the instruments improve. But it refused to vanish. The more precisely astronomers measured, the more firmly that little surplus held its ground. It was real, and that was exactly what made it so unsettling. The same law that seemed to govern the heavens without a single exception was failing by a hair in the one place no one could look away from, in plain arithmetic on the nearest planet to the sun. Something was missing from the picture. The clockwork had a flaw in it, and somewhere out in the dark, someone would have to find what was causing it. If you find this calm walk through the history of the night sky restful, you are warmly welcome to subscribe and stay with me a while. There is no hurry here at all, so settle back, close your eyes, and listen as we continue the story. To track down the missing piece, the world would turn to a particular kind of mind. And in the middle of the 1800s, there was no finer example of it than a Frenchman named Urbain Le Verrier. He was not a man who spent his nights shivering at the eyepiece of a telescope. He was a calculator, a worker of immense and exacting patience, the sort of person who could sit with great columns of numbers for months on end and bend them until they confessed their secrets. He was also, by most accounts, a difficult man, proud, sharp-tongued, and quick to quarrel. But no one alive doubted the raw power of his arithmetic. His great triumph had come a little earlier, and it grew out of a different planet's misbehavior. Far out beyond Saturn lay Uranus, a world that had been stumbled upon by accident in the previous century. Astronomers had been tracking it ever since, and Uranus, much like Mercury, refused to follow its predicted path. It would run ahead of schedule for a stretch of years, then fall behind, drifting off course in a way that Newton's rule seemed unable to explain. Two very different explanations were possible. Perhaps Newton's law itself broke down at such an enormous distance from the sun, weakening in some unknown manner. Or perhaps the law was flawless, and there was simply something out there that no one had yet seen. Another planet, farther still, whose unseen pull was tugging Uranus first forward and then back as the two worlds slowly passed one another. Le Verrier chose to trust the law completely. He assumed the unseen planet was real, and then he set himself an almost unimaginable task to work backward from the wandering of Uranus and calculate precisely where in the sky this hidden world must be. It was a staggering thing to attempt. He had to reckon not only how heavy this unknown planet might be and how far away it lay, but exactly where along its slow circuit it sat at that very moment, so that someone could aim a telescope at a single small patch of darkness and find it waiting there. Across the Channel, in England, a young mathematician named John Couch Adams was quietly wrestling with the same puzzle and arriving at much the same answer, though his work would languish unnoticed for far too long. Le Verrier finished his own calculation and, unable to persuade the astronomers of his own country to drop everything and search, sent his prediction in a letter to an observatory in Berlin. What happened next became one of the most celebrated nights in the whole history of science. The letter reached the Berlin Observatory, and a young astronomer there named Johann Galle turned the great telescope toward the patch of sky that Le Verrier's numbers had marked out. That very evening, almost at once, he found it. a faint point of light that appeared on no star chart, sitting within a single degree of the spot where the Frenchman's pen had placed it. It was a new planet, an eighth world, soon to be named Neptune. And it had been discovered not by sweeping the heavens in blind hope, but by pure calculation, located in the dark exactly where the mathematics had insisted it would be. The effect of this on the world was electric. Here was proof, as dramatic as anyone could ever have wished for, that the universe truly was the glass machine Newton had described, and that a clever enough person, armed only with the law of gravity, could reveal entire worlds that no eye had ever glimpsed. Leverrier became famous across Europe almost overnight. People spoke in wonder of the man who had discovered a planet at the tip of his pen, who had weighed the invisible and then pointed straight to it in the sky. It was a kind of magic dressed up in arithmetic, and it carried a quiet, dangerous lesson along with all the glory. The lesson that whenever a planet stepped out of line, the answer would surely be another planet, waiting patiently in the dark to be found. That lesson would soon be carried back across the solar system, all the way inward to the small, misbehaving world closest to the sun. It was almost inevitable that Leverrier, having conquered the outer edge of the known system, would turn his attention to its inner edge. Mercury's stubborn surplus had troubled astronomers for years, and here, at last, was the one man in the world who had already shown exactly what to do with a planet that would not behave. He had a method that had worked spectacularly once before. He would simply use it again. So he settled in to work on Mercury with the same relentless patience he had once spent on Uranus. He gathered every observation he could lay his hands on. Decades of careful measurements of when Mercury crossed certain points, where it sat against the background stars, how its loop slowly rotated over the years. He added up the pull of Venus, the heavy distant tug of Jupiter, the contributions of the Earth and all the rest, accounting for each known body with all the precision his arithmetic could command. And when he had at last subtracted every cause he could name, the same small surplus remained, that 43 seconds of arc each century, quietly refusing to go away. For a mind shaped by the triumph of Neptune, the conclusion was almost impossible to resist. Out beyond Uranus, an unexplained motion had meant an unseen planet farther out. Here, in close to the Sun, an unexplained motion in Mercury surely meant an unseen something farther in. A hidden mass circling between Mercury and the Sun, tugging on Mercury as the two of them passed and pushing its loop a little faster around. Leverrier announced his conclusion in the year 1859. The heavens, he declared, were concealing a world, or at the very least a great deal of matter, in the narrow furnace of space that lies inside Mercury's orbit. The idea needed a name, and the one that settled upon it was perfect for its home. This new world would orbit in the fiercest heat anywhere in the solar system, scorched and blazing beside the sun itself, and so it was christened Vulcan, after the old Roman god of fire and the forge, the blacksmith of the gods, who laboured at his furnace deep beneath the earth. The name suited a planet imagined to live inside the flames. And because the idea came from the very man who had found Neptune, the wider world was inclined to take Vulcan seriously from the start. There was, of course, an obvious objection waiting to be raised. If a whole planet was truly circling so near the sun, then why had no one ever seen it? But Leverrier and his supporters had a ready answer, and it was a genuinely good one. A world that close to the sun would almost always be drowned in glare, rising and setting nearly together with the sun, hidden away in the full blaze of daylight. There were only 2 moments when such a planet might possibly betray itself. One was during a transit, a rare passage when the planet crossed directly between us and the sun, appearing as a tiny dark dot creeping slowly across that brilliant disk. The other was during a total eclipse, when the moon blotted out the sun, and for a few precious minutes, the sky around it grew dark enough to reveal whatever might be lurking nearby. In a way, this answer was the most fateful part of the entire affair. It meant that Vulcan could be both real and almost never visible, that its long absence from the sky proved nothing at all because the sun's glare gave it a permanent place to hide. The planet had been conjured out of a tiny discrepancy by the most respected calculator alive, given a name worthy of its fiery home, and fitted out with a perfect explanation for why no one had managed to catch it yet. Now all that remained was for someone to look up at exactly the right moment and see it. And in a world so thoroughly primed to believe, with thousands of eager eyes beginning to turn towards the sun, it would not be long at all before someone did, or believed with all their heart that they had. The someone, when at last he came forward, was not a famous astronomer at all. He was a country doctor named Edmond Lescarbot, who lived and practiced in a small village out on the wide, flat farmland southwest of Paris. By day, he tended to the ordinary illnesses of his neighbours. But in his spare hours, he was a devoted amateur of the sky, and he had built himself a modest little observatory fitted with a small telescope and a collection of instruments cobbled together with the ingenuity of a man who could not afford the finest tools. His claim reached back to a spring day before Leverrier had even published his idea, the 26th of March, 1859. On that afternoon, Lescarbot said he had been studying the sun through his telescope when he noticed a small, perfectly round black spot near its edge, a spot that he was certain had not been there a little while before. As he watched, the dot began to move, creeping slowly across the bright face of the sun in a straight and steady line, exactly as a planet in transit ought to do. He did his best to time it and to mark its path, improvising his measurements with whatever lay close at hand, even falling back on the beats of his own pulse to count the seconds when he had nothing better. Then the little spot slid off the far edge of the sun and was gone. For months afterward, he told almost no one, uncertain of what he had really seen, and perhaps a little afraid of being laughed at. But later that same year, he learned that the great Leverrier had announced the existence of an unseen inner planet, and the doctor realized with a jolt that his own little black dot might be precisely the thing that the famous mathematician was searching for. So he sat down and wrote out a careful letter describing his observation and sent it off to Paris. What happened next has the quality of a story almost too good to be true, though it seems to have unfolded much as it was later told. Leverrier did not simply write a polite reply. On the very last day of the year, he travelled out from Paris to the doctor's remote village, arriving more or less unannounced, determined to take the measure of this man for himself, and he was not gentle about it. Convinced that any true discovery had to survive hard questioning, he confronted Lescabaut almost like a prosecutor, demanding to inspect the instruments, challenging his methods, pressing him on exactly how he had measured the moments and the angles, watching keenly for any sign that the doctor might be a fool or a fraud. But the country doctor held up under the interrogation. He showed off his homemade equipment, his improvised records, the scraps of paper on which he had jotted his timings in the heat of the moment. He answered the sharp questions with the plain, unpolished honesty of a man who genuinely believed he had seen what he described. By the end of that long visit, Leverrier was satisfied. Here, he believed, was an honest witness with no reason on earth to lie, who had unknowingly caught the very planet that the mathematics demanded. The doctor's crude little numbers were exactly the kind of evidence Leverrier had been waiting for. He carried the doctor's measurements back to Paris and fed them into his calculations, working out from that single brief transit how large Vulcan must be and how it must travel around the sun. He then presented the result to the learned men of the Academy with the confidence of someone delivering a second Neptune. The humble doctor, for his part, was rewarded for his contribution to science and honoured with one of his country's highest distinctions, the sort of recognition that a village physician could never have dreamed of receiving. For a brief and shining moment, it all fit together. The anomaly, the prediction, the witness, and the orbit. Vulcan seemed not merely possible, but very nearly proven. And so, the wider world was invited to join the hunt. Once the great Leverrier had given his blessing to the doctor's sighting, the search for Vulcan spread outward like ripples on a still pond. Astronomers in observatories across Europe and America began to give the sun a new and watchful kind of attention, and so did a vast company of amateurs, school teachers, country clergymen, retired officers, anyone at all with a small telescope and a piece of darkened glass to shield their eyes. A new planet was waiting to be caught in the act of crossing the sun, and the glory of catching it lay there in the open for whoever happened to be looking at the right moment. Reports began to arrive, and they kept on arriving for years. From here and from there came accounts of small dark spots seen drifting across the face of the sun, each one offered up as a possible glimpse of the hidden world. Enthusiasts went back through the old records too, combing the notebooks of earlier observers, and turned up scattered mentions of unexplained spots from decades past that now, in this new light, looked as though they might have been Vulcan all along. The evidence appeared to be piling up handsomely. The planet seemed to be leaving its footprints in every place that people thought to look for them. But there was a quiet trouble running underneath all this excitement, and it had far less to do with the sky than with the people who were watching it. When you tell a great many observers that a planet is there to be found, and that finding it would bring real honour, you quietly change what they notice and what they allow themselves to doubt. A small flaw in a lens, a bird passing in the distance, a sunspot of the perfectly ordinary kind, a lingering afterimage swimming across a tired eye, any of these could become, in a hopeful mind, the long-sought world at last. The watchers were not lying. They were doing something far more human and far harder to guard against. They were seeing the thing they had been led to expect. This is one of the very oldest traps in all of observation, and it catches the careful just as easily as the careless. We naturally tend to remember the evidence that fits the story we are hoping for, and to explain away the evidence that does not. A spot that crossed the sun at just the right speed was hailed as Vulcan. A spot that behaved wrongly was dismissed as a mere blemish and quietly forgotten. Bit by bit, without anyone ever deciding to deceive, the great collection of sightings was sifted and shaped by hope until it seemed to tell one single, tidy tale. And yet, when the cooler-headed astronomers tried to fit all of those sightings together, the tidy tale fell apart in their hands. A real planet must follow one fixed path around the sun, returning on a strict and knowable schedule, crossing the sun's face only at certain calculable times. But the reported sightings simply would not line up. The dates and the positions pointed to no single consistent orbit. One observation flatly contradicted the next. Le Verrier himself was forced to keep adjusting his figures, revising the size and the path of his planet to chase after the latest claims, and still the pieces refused to settle into one coherent world. Most troubling of all was a far simpler test that the planet kept on failing. If Vulcan truly circled the sun along a regular orbit, then it ought to cross the sun's face at predictable moments, and astronomers could calculate when those crossings should occur and gather to watch for them. So they did calculate, and they did gather, and at the appointed times they aimed their instruments squarely at the sun and waited. And nothing came. The dark dot did not appear on schedule. For every breathless report of a chance sighting, there was a quiet, unsettling silence where a predicted transit ought to have been. The hunt was producing a steady supply of glimpses, but never once the single thing that would have settled the whole matter. A planet that showed up reliably when and where the mathematics said that it must. If the sun's glare was the great obstacle, then there was one rare circumstance that swept the glare aside entirely, and astronomers learned to pin their highest hopes upon it. During a total eclipse of the sun, the moon slides squarely across the face of the sun and blots it out. And for a few short minutes, the day itself collapses into an eerie twilight. The sky around the hidden sun grows dark enough for the stars to come out, and dark enough, perhaps, for a small inner planet to reveal itself, shining in the very region that was otherwise quite impossible to search. These minutes were precious and terribly few. A total eclipse touches any given spot on the Earth's surface only once in a very long while, sweeping along a narrow track and then moving on. So astronomers became travelers. They hauled their telescopes and cameras to whatever remote corner of the world the next eclipse happened to cross, setting up in deserts and on mountainsides and on far-off plains, gambling weeks of preparation on a sky that might cloud over at the worst possible moment. And among all the things they hoped to study in those fleeting minutes of darkness, the chance to catch Vulcan at last was a glittering prize. The most famous of all these attempts came in the summer of 1878, when a total eclipse swept across the western frontier of the United States, its shadow crossing the high plains and the mountains of territories like Wyoming and Colorado. The clear, thin, dry air of the American West promised superb viewing, and observers gathered all along the path of the shadow in considerable numbers, among them some of the most respected names in the science of the day. The stakes were understood by everyone present. If Vulcan was real, then here was a fine chance to settle the question once and for all. When the moon's shadow finally fell and the brief darkness came rushing in, two seasoned observers in particular came away utterly convinced that they had succeeded. One was James Craig Watson, a celebrated hunter of asteroids with dozens of genuine discoveries already to his name, a man whose word carried real weight in his field. The other was Lewis Swift, another careful and experienced observer. Working from separate locations along the eclipse track, each man reported seeing one or more star-like points of light close beside the darkened sun, sitting in places where no known star was charted. Objects that looked to them like the missing inner world caught out in the open at last. For a short while, the announcement caused a genuine sensation, and it seemed that the long hunt might finally have ended in triumph out on the American plains. But the triumph slipped away almost as quickly as it had arrived. When the two observers' descriptions were laid side by side and compared, the positions they had reported did not agree with one another, nor could the supposed planets be reconciled into any sensible orbit at all. Skeptical astronomers were quick to point out that ordinary stars glimpsed in the strange rush and gloom of an eclipse and then matched against imperfect charts could very easily have been mistaken for something new and remarkable. In the cold light of later analysis, the most likely explanation was that the two men, caught up in the pressure of those few extraordinary minutes, had simply recorded a pair of known stars and misjudged precisely where they lay. It was the same disappointing pattern that had shadowed the whole affair from the beginning, only sharper now, because the witnesses were so trustworthy and the conditions so very favourable. The closer anyone looked, the more the planet seemed to dissolve. Every promising glimpse, once set beside the others and tested against the strict demands of a real orbit, came apart again into error and coincidence and honest mistake. The eclipse expeditions had offered the cleanest possible look into the forbidden zone beside the sun, and what they kept finding there again and again was nothing that would hold still long enough to be a world. By the 1870s, the mood among the careful astronomers had begun to shift, slowly and a little sadly, away from excitement and toward doubt. Too much time had now passed, and too many searches had quietly failed for the old confidence to survive entirely untouched. The pattern, once you stepped back from the individual sightings and looked at the whole, was very hard to ignore. A steady stream of glimpses, none of which ever agreed with the others, and an absolute ringing silence wherever a real planet should have announced itself on schedule. The deepest problem was always the same one. A genuine planet is not a matter of opinion or impression. It is a solid body following one definite path, and from that path, everything else must follow with an iron consistency. If Vulcan truly existed and was large enough to disturb the orbit of Mercury, then it had to be large enough and bright enough to be caught crossing the sun at calculable times by many separate observers, all in agreement with one another. No such consistent body could ever be found. The sightings could not be woven together into a single orbit, no matter how cleverly the figures were stretched, and the predicted transits stubbornly refused to occur. Each fresh attempt to pin the planet down only widened the gap between what the theory promised and what the sky was willing to deliver. The skeptics began to say aloud what had long been whispered in private, that perhaps there was no planet there at all. A world heavy enough to nudge Mercury by the needed amount could hardly have slipped past every eye for so many years, through so many watched eclipses and so many predicted transits. Either the planet was real and yet somehow impossibly elusive, which strained belief to its limit, or else the anomaly in Mercury's motion had some altogether different cause, something that no telescope, however patient and however fine, would ever manage to reveal, because it was not a thing that could be seen at all. Leverrier himself, for his part, never once let go. The planet was the very child of his calculations, the logical mate of his great Neptune, and he defended it and adjusted it and believed in it right to the end. That end came in the autumn of 1877. By a strange turn that his admirers could not help but remark upon, he died upon the very date of the year on which Neptune had been found 3 decades before. The same calendar day that had marked his single greatest triumph now coming round to mark his death. He went to his grave convinced that the inner planet was real, that somewhere in the glare a small fiery world was circling the sun, exactly as his arithmetic had always insisted it must. With its great champion gone, the hunt lost much of its fire, though it did not stop all at once. Sheer momentum and old hope kept a few stubborn searchers at their telescopes for years more. But the tide had plainly turned. More and more astronomers quietly set Vulcan aside, not because anyone had managed to prove that it could not exist, but simply because the long failure to find it had grown too heavy to keep carrying. And this left behind a genuinely uncomfortable puzzle, one that was, in its own way, worse than the puzzle they had started with. The planet might well be a phantom, but the anomaly most certainly was not. Mercury really was drifting by those 43 seconds of arc each century. The measurement was solid, confirmed and reconfirmed many times over. So if no hidden world was nudging it along, then something else was, something nobody could yet name. The mystery had not been solved. It had only been stripped of its most comforting answer and left standing there, open and unexplained, waiting for a far stranger solution than anyone had thought to imagine. For more than half a century, the little surplus in Mercury's orbit sat there like a splinter that no one could quite manage to remove. The planet that was supposed to explain it had faded away into doubt, and yet the 43 seconds of arc remained, as real and as stubborn as they had ever been. Various thinkers tried hard to account for the drift in other ways. Perhaps the sun was not a perfect sphere after all, but slightly flattened, its bulging shape disturbing Mercury as it passed. Perhaps a faint haze of fine dust circled close to the sun and dragged at the little planet. Perhaps the law of gravity itself stood in need of some tiny adjustment at these closest of distances. But each proposed remedy either failed to produce the right number, or it solved the one problem only by creating new ones that were worse. The splinter stayed firmly in place. The answer, when it finally arrived, came from a direction that no one patiently watching the sun had ever thought to look. In the early years of the 20th century, a physicist named Albert Einstein was busy rebuilding the entire idea of gravity from the ground up. Newton had pictured gravity as a force, an invisible pull reaching across the empty gulf of space from one body to another. Einstein came to see it altogether differently. In his new picture, space and time were not a fixed and empty stage upon which events simply played themselves out, but something flexible, something that could be bent and stretched and curved. A massive object like the sun, he proposed, actually warps the space and time in the region around it, and what we feel as the pull of gravity is really nothing more than the natural motion of things following the curves of those warped surroundings. This was a strange and beautiful idea, and it carried a quiet consequence for the planets. If space itself is curved most steeply in close to a great mass, then the planet that swings nearest the sun, diving the deepest into that curvature, ought to feel the effect more strongly than any other. And the planet that swings nearest the sun, of course, is Mercury. In Einstein's picture, Mercury was not merely orbiting through plain empty space according to a simple force, it was tracing its path through gently warped surroundings, and that warping would make its loop turn just a little more than Newton's older mathematics had ever been able to predict. In the autumn of 1915, Einstein worked out exactly how much extra turning his new theory required for Mercury, and the moment of that calculation has become one of the most cherished in the entire history of science. He did not have to invent a hidden planet, nor a flattened sun, nor a cloud of dust, nor any other special ingredient added in by hand to make the books balance. He simply applied his equations to the nearest planet and let the answer fall out of them on its own. And out it came, an additional drift of 43 seconds of arc each century. The very number that had defied every explanation for 56 long years, matching the carefully measured anomaly almost perfectly. The effect of this on Einstein was overwhelming. By his own account, he was so excited that he could not work for several days afterward, his heart racing, struck by the powerful sense that nature itself had answered him directly. He had reached for his equations in order to understand the deep structure of gravity, and they had handed him, almost as if for free, the solution to a riddle that had baffled the greatest astronomers alive for 2 full generations. The missing cause of Mercury's wandering had never been a planet at all. It was the curvature of space and time near the sun, invisible, untouchable, and woven into the very fabric of the universe. And with that, Vulcan quietly dissolved. It was not chased away by a sharper telescope, nor by some final and decisive failure to spot it during an eclipse. It was simply rendered unnecessary, gently dismissed by a deeper understanding that explained the anomaly without needing any extra world at all. The planet that had been conjured into being to fill a gap vanished the moment that gap was filled by something else entirely. There is a deep irony in this ending, and a kind of justice in it too. The same tiny discrepancy that had once summoned an imaginary planet into existence became, half a century later, one of the very first great proofs that Einstein's revolutionary view of gravity was correct. The 43 seconds of arc had work left to do. They had merely been waiting for the right person to come along and ask them the right question. And so the planet Vulcan was gone, erased not by disproof, but by something deeper rising up to take its place. And yet, the strange, scorched stretch of space between Mercury and the Sun has never entirely lost its hold upon the imagination. The great planet is no longer expected to be there at all, but a fainter possibility still lingers, a kind of ghost of the old idea, and it goes by a name that openly remembers its ancestor. Astronomers call them Vulcanoids. Not one single sizable world, but the possibility of small bodies, little rocky asteroids that might somehow survive within a narrow band of stable orbits very close to the Sun. There is nothing in the laws of physics that strictly forbids them. A handful of small objects, if they formed there long ago or drifted inward at some point and found a safe perch, could in principle circle quietly in that zone, far too small to disturb any planet, far too small ever to have been the grand Vulcan of old, but real all the same. The idea is modest where the original was grand, and that very modesty is part of why it has never been entirely ruled out. The difficulty, naturally, is the same one that doomed the original hunt from the beginning, the unbearable nearness of the Sun. Anything in that region is washed in glare and very nearly impossible to glimpse from the ground, except in the brief darkness of an eclipse. So, the search for Vulcanoids has carried on instead with the tools of a newer age. Observers have flown cameras to great heights aboard high-altitude aircraft, climbing above the thickest and brightest layers of the air. Spacecraft built to stare endlessly at the Sun have swept that inner region for any small body crossing through it. Each new search refines the limit just a little further, and so far, after all of that effort, nothing has been found. If any Vulcanoids exist at all, they must be both few and small, hiding right at the very edge of what our instruments are able to detect. But the most lasting thing this whole affair left behind is not really up in the sky at all. It is a lesson about the people who look at the sky, and in truth, about all of us. Vulcan was not the invention of fools or charlatans. It was believed in by brilliant, careful, honest people, the finest mathematician of his age among them, precisely because they were so brilliant and so careful, and because they had been proven right so spectacularly once before. Leverrier's triumph with Neptune had taught the whole world to expect that every wandering planet must hide another planet. And so, when Mercury wandered, an inner planet was exactly what they all went looking for. And expectation, it turns out, has a quiet way of furnishing the very thing it expects. That is the warning the story carries gently down to us. We do not first see the world plainly and then form our beliefs about it. Far more often, our beliefs reach out ahead of us and quietly shape what we will allow ourselves to see. The hopeful observers who caught their planet crossing the Sun were not inventing their sightings out of thin air. They were taking the ordinary specks and stars and blemishes that had always been there and reading into them the story they had been so well prepared to find. It is a thing the mind does so smoothly that we hardly ever catch it in the act, and the surest guard against it is exactly the cold, stubborn testing that finally dissolved Vulcan, the plain insistence that a real thing must show up reliably, must agree with itself, and must survive every honest attempt to prove it false. And yet the tale is not, in the end, a sad one, nor merely a caution to be filed away. The anomaly that started it all was genuine, and the rigour that chased it was genuine too. And the long pursuit of a planet that never existed led, by a winding and unexpected road, straight to one of the deepest truths we have ever learned about the universe. The Watchers were wrong about Vulcan, but they were not wrong to look. They had found a real loose thread in the fabric of the heavens, and in pulling at it patiently for half a century, they helped to unravel the old idea of gravity itself and to reveal the stranger, truer thing that had been lying quietly beneath it all along. Tonight, if you could somehow lift the daytime glare away and gaze into the space close beside the sun, you would find it empty of the world that so many people once longed so badly to see. Mercury is still there, of course, swinging around the sun every 88 days, its loop still slowly turning, still drifting by those 43 seconds of arc each century. But the drift is no longer a mystery, and no hidden planet rides along beside it in the dark. The space where Vulcan was once imagined is simply quiet, curved emptiness, bent gently by the sun's great mass, exactly as much as it needs to be, and not the smallest bit more. There is something restful in that emptiness, once you settle in and sit with it. For more than 50 years, some of the cleverest people alive were certain that a small, fiery world was circling there, and they searched for it across whole continents and through eclipses and over the entire face of the sun. And they were mistaken, and the mistake was an honourable one, and out of it grew a far deeper understanding than the one they had begun with. Knowledge does not always move forward by finding the thing we set out to find. Sometimes it moves forward in the moment we finally understand why we never could. So let the planet that dissolved be a gentle companion as you drift off now, not a failure, but a quiet reminder of how patiently the world gives up its secrets, and how often the answer we are finally handed is stranger and finer than the one we first thought to ask for. The little wobble in Mercury's path is settled now, folded quietly into the very shape of space itself. The long hunt is over. The watchers have set down their telescopes for good, and that small, empty region beside the sun turns on exactly as it should, asking nothing further of anyone at all, while you let the whole day go and ease down softly into sleep. Thank you for listening.